We're really just looking at how spread out the data are. All right, so in the first example, we're talking about a variety related to brands of batteries, and we want to know, based on the dot plots, whether one has battery lives that tend to differ more than the other. All right, and just based off of visual inspection, I mean, you just look at it, you can determine that brand, which one?
B.
Brand B. And that's because the data are more spread out. I'm going to write dispersed.
Data.
All right. It saves me a word. Dispersed and spread out mean the same thing. All right. So it's a nice way of making it a little bit more concise. Just understand, it's kind of a weird thing, but the word data is actually a plural. That's why, it looks weird when I write data are. You want to say data is, but that's not correct because data is plural.
So what's like the noun?
Datum. Right?
Datum.
Yeah.
What? I got one good
Clay, do you
datum.
remember? No. Clay used to get that all the time.
I'm gonna yeah, I'm literally shit.
One
Clay used
datum
to yell
of
at us
memory.
all the time. It's like,
Yeah, I don't think data are units of memory, but that's okay.
we had like a whole 20-minute argument about data.
If a computing device has memory, then it can transport data. But
In 3 minutes.
it's not like I have like 3.2 megadatas of memory. Like it's not all right, measures of central tendency give a good description of data, but they do not let us know how much variation there is in the data set. Now, the measures of central tendency, it's really kind of an umbrella topic, very important. When I say measures of central tendency, I'm talking about three things in particular. Do you know what they are? They all start with an M.
Medium.
Mean, median, and mode. Right? So those are the three values that give us a sense of the center of the data. All right. So they give us a good idea. They give us some information about the data, and oftentimes it's all we really want to know about the data. All right. But even when I talk about test scores in the class, I talk about the mean and the standard deviation. All right. And I'm kind of paying that off now because the standard deviation is telling us how spread out the data are. Because if I tell you that the mean of a test score, of a set of test scores is 80. You're like, okay. But then I tell you the standard deviation is 10. You say, okay, it's spread out a little bit. So then you think, okay, I have hope that maybe I'm on the high side, right? But if I tell you that the mean is 80, so the same exact measure of center, so average up all the scores and I get an 80, but I tell you the standard deviation is equal to 0, everybody got an 80. All right.
Oh.
So that's a little bit of a different story. All right. If I tell you the standard deviation is 1, there's a little bit of spread, but not as much spread as if there's a standard deviation of 10. All right. If there's a standard deviation of 30, then it's like all over the place, but it still averages out to an 80. So the 80 tells you something about the data, but it doesn't tell you everything. All right. And so that's where we get into things like interquartile range, which is a measure of variation. So is range itself. But oftentimes, that doesn't really tell you the full story. I mean, if I were to tell you that the average on a test was 80 and the range was, let's say, a 70, I'd be like, okay, 30 and 100, low and high, average 80, you still don't really know where you would fall in this whole thing. All right? And it could also be, I suppose, like a 15 and an 85 as the low and high, but it's more likely that it's like a 3 and a, well, it couldn't be a 10 and an 80 because once you throw the 10 in there, then the mean would have to be pulled to a value that's less than 80. All right, so we have range. Interquartile range is telling us the spread of the middle 50% of the data. So that's a meaningful value. But then we'll get into standard deviation, which is something that we can get on the calculator. All right. We could also get this IQR, interquartile range, from the calculator, because IQR is just the difference between your upper quartile and your lower quartile. All right. In calculator speak, Q3 minus Q1. All right, mine's out. Now, small data set, so there's no reason why you couldn't be able to do this by hand. Because, and I'll show you real quick, because with a small data set, sometimes it's a little easier to do it by hand. But I'll show you again how to do it on the calculator, both calculators. So, if you want to find your quartile values, what you want to do is chop the data in half and then chop the data in half again. All right, so if we're finding quarters. All right, so I count to the middle. So I'm just going to find the highest and lowest values and work my way into the center. All right, I have two center values here, which means that the median is smack dab in between them. Smack dab. No. All right, so the median would be, or at least how would I find the median here? Add them together and divide by 2. All right, so 101?
So it's like the mean of the medians.
It's the mean of the two median values, yeah. All right, so that's our median. Not what we're looking for. What I want to then do is find the median of the lower half of data, but the data have to be organized in either ascending or descending order, meaning they have to either increase or decrease throughout the entire set. It can't be just jumbled up. All right, so the middle of the lower half of data would be the number 94. That's my LQ. My lower quartile. And then the median of the upper half of data would be 113, which would be my upper quartile. The only thing I'm looking for when I'm trying to find the IQR is the difference between those two values. So 113 minus 94 would 19? Very good. All right. Again, small data set, you may consider doing it by hand. Larger data sets, you definitely want to go to the calculator. But I'll show you how to do it on the calculator anyway. All right, so stat, edit. All right, quick review on how to clear data. You go to your column heading, clear, enter. All right, I'm gonna wipe out both data sets because I did this for another class. Pull the top, then pull the bottom.
Wait, what?
Pull the top.
What do you mean? This?
Yep. Now pull the bottom.
Like without closing it?
Correct. Yeah, I have no idea why it works that way. That's just the way it is. All right, so we type in our data. And you know what? I'll use, oh, that's funny. I mean, not from where you're sitting. I have a really nice looking calculator right here on my screen.
What?
Like on my iPad screen. It looks beautiful. It's like, no, it sure isn't. You know what we can do? We can do this simultaneously. We'll take the second data set and type it into L2. I'll show you a little strategy here. All right, so quick question. What's the biggest thing or the biggest concern when it comes to using the calculator to do these kind of problems?
It'll all get wiped out.
Yeah, I mean, that's a concern, definitely. The biggest one.
Remembering how to do it.
even better than that.
Watching.
Doing it right.
Well, yeah, that's the thing. And what I mean by that is actually typing in the data correctly, because when you do a free response question related to this, so not a multiple choice question, test, Regents exam, there isn't really much work to show. It's answer. And then I look at that 3, 4, 5 point question and I look at your answer and I say correct or incorrect. If you type the data in incorrectly, you're going to get the wrong answer. And there won't be any real supporting work. So I won't be able to give you any partial credit. So that means you have to spend, like, you're done with the test with 15 minutes to go before the end of the period, go back and double check every single thing you did on your calculator, and then triple check it. Because the only way you're going to screw it up is by typing in the data incorrectly. So now that I said all that, I'll probably screw this all up, but it'll at least prove a point. All right, so stat, calc, option 1, it defaults to L1. I'm going to calculate, scroll down, I get my Q1 and Q3 values, which is what I had there, so that's good news. All right, so now I typed in my other data set, brand B, I typed that into L2, so I'm going to do that again, stat calc 1, but now I'm going to change list to L2 because that's where my data are. If you don't like where my data are, because it sounds funny, you could say where my data set is, because data set is singular. Yeah. Second 2. So 1, 2, 3, 4, 5, and 6, right above those numbers, you see all the L's associated with them. So then hit calculate. You get your summary statistics for my second list of data, but specifically, I just wanted LQ and UQ, so 84 and 117.5. So 84. 117.5 minus 84 is what? 33.5? Is that right? Okay. So would you prefer a battery brand that has battery lives that do not vary much from battery to battery? Why or why not? Variation is kind of an interesting thing. I don't know. I have an airport example that I always use for when it comes to explaining variation. And I also go with the fast food example, but that's less and less now that they have the on-the-go apps. But the airport one is good, right? Because you have 2 possible airports, and I actually frequent 3 different airports, right? Newark, LaGuardia, and JFK, right? Newark has the quickest security line, but it's the furthest one away, all right? LaGuardia is the closest one, but it has the worst security line, and JFK is the one in the middle. Security line's okay, but traffic is an abomination. All right, so you get a lot of different variables coming into play here. All right, wherever possible, I like to go to Newark because there's less variation in the security line. All right, when I get there, I know that I'm through that security line in 15 minutes. Well, now I have TSA pre-check, it's like 5 minutes, but before I had TSA pre-check, it was like 15 minutes, you're through security, and that's the end of it. All right, so I know I had to drive a little further. It takes longer to get there, but I'm gonna get through, all right? You go to JFK, for example, if you get lucky, you're through in 5 minutes. If you don't get lucky, you're waiting an hour to get through security. You've experienced that?
No.
Yes.
I've been through like 5 minutes like every time.
Oh, lucky you.
Yeah. I'm just a wizard. Like that, you know?
And then, of course, there's the, you've been randomly selected for additional screening. They're like, yeah, we're due for another one. You, come here. So here's the deal.
Whenever I go myself, I always get
If you have to go to JFK, then what ends up happening is you have to budget time for the worst case scenario. All right, so you have to go there like 3 hours before your flight, and then what happens when you do that? You
end up sitting there for.
you get through security line in 5 minutes, and you end up sitting at the gate for 2 hours and 55 minutes, right? So the variation ends up becoming a problem. If it becomes predictable, lack of variation, folks, very important. The side conversation can happen later. This is probably the most important part of the unit. If you can minimize variation, then you strengthen predictability. All right? Anytime that you can strengthen predictability, it means that you can then forecast. All right? Think about something like the weather. All right? 20 years ago, it was a crapshoot. If they said it was going to be sunny today, it'd be like, all right, I'll bring my raincoat just in case. Nowadays, if they say it's going to be sunny today, it's still in the back of my mind, all right, well, maybe they'll be wrong, but most of the time I'm feeling pretty good. Like snowstorms, like they say it's going to snow, it's going to snow. We may not get the 8 to 12 inches that they say we're going to get, but we're going to get something, all right? It becomes more predictable, right, because variation is limited, all right? That's the most important part about statistics. Anytime you can restrict variation, you strengthen predictability. Now, if you're in a class that just took a test and it had a 70 average with 0 standard deviation, yeah, it's predictable. Yes, I can say with great confidence that every one of my students got a 70. However, I am not happy about that, right? So that's a little byproduct of it. It's not always good news, but it's predictable, and predictable is a good thing, all right? So, or at least it's a thing that you can rely upon, all right? So, would you prefer a battery brand that has lives that do not vary much? It's just worded weirdly. Why or why not? Less variation. More predictability.
I see Haley's gonna get that one.
You know those questions on the Regents exam that so far you still haven't been able to do? The ones that ask you to find a regression equation? All that is variation. Right? What you're trying to do is find a line that limits the variation from the data points to that line. All right, it's a very complicated process if you have to do it by hand, but we'll learn how to do it on the calculator. But it's all rooted in this concept. This concept of standard deviation is the single most important concept in statistics. All right. Standard deviation of a data set tells us on average how far a data point is away from the mean of that data set. The larger the standard deviation, the greater the variation within the data set. Kind of an oversimplification of the definition, because my airport example, the fact that I had to wait on a drive-through this morning for 15 minutes when some other time, it's drive-through, it's a pizzeria that also serves breakfast. It's not like, it's not fast food.
Pizza, it's just a stick of butter on a pancake covered in marinara sauce.
Actually, I've had like breakfast pizza rolls before at an airport. But yeah, it didn't really work out too well. Predictability is the way to go. Capsule summary of all calculator approaches for you. Take some time and read through that.
I'll catch a quick picture of this. This?
I hate the way they word things.
It's in your pack on Whiteboard. You need a picture.
All right. Yeah, I know. There's people who hate it.
See, that's just me.
Table below shows the lines of brand A. Nothing different. Fun fact, we already have these answers. We've already done it.
Oh, it's the same data, but...
It's exactly the same data.
Oh, I was right.
We need to find the mean and the standard deviation. Now,
The mean is easy. 101.
I'm going to run through the calculation again. Stat calc 1.
Hold. Stat, calc.
My data are listed in L1, or at least this data set. Second one to get L1, and then we go right to calculate. All right, so that's all the information we had before. You scroll down, you get all your 5-number summary stuff, but we actually want to be living in the top portion of this summary menu. The mean is X bar. I think it's obvious what we're looking for here. So X bar, it's called X bar if you didn't know that. 101 hours. All right, units are a must. Find the standard deviation of the data set. Now, this is the issue that we come in, that comes into play. Standard deviation takes on two forms. You have a sample standard deviation. And you have a population standard deviation. All right, the sample standard deviation is abbreviated with an S sub x. All right, so you know what it is. Population standard deviation is sigma sub x. All right, it's a O with a little tail at the top. All right,
Sigma.
lowercase sigma sub x. All right, Greek letter sigma. All right, the difference between a sample and a population. Population is all of a group, or every element within a group. I'll just abbreviate that with all. Sample is sum. I would almost work same. It's not the same. It's sum of the group. All right. There's different techniques involved in sampling, which we're not really going to get to in this course, or get into in this course. It's not part of the curriculum. You'll deal with it in Algebra 2, and then AP Stat, if that's something you want to take, or Prob and Stat is the non-AP version of that you can take down the line.
I'm taking no AP now out here. Sorry about that.
You say that now. Then you find out that you're not going to get into the college you want to unless you do.
That's actually facts.
Yeah. So it's like, oh, yeah, I remember when I said that one time. So anyway, what you have to do is decide whether you're dealing with a sample or a population. And then choose the appropriate standard deviation. So which one's appropriate here?
Oh,
Sample.
rip. Yeah, I don't know anything on it.
How do we know that?
This says.
Hours, right?
I don't know.
Good point.
Okay, so how do you choose which one?
How do we choose which one?
Like, how do you know if it's a sample or like all?
How do you know if it's a sample? You see what I'm doing here? I'm taking your question and I'm asking the class your question, hoping that somebody will answer.
Oh,
it.
I see.
It says it.
The way around.
If it was all
In the
at C,
parentheses
you would
after
see
the
all of the
X.
independent battery lives of
In the
every single
parentheses.
battery that the company had.
Okay. I know it's not all the batteries.
This is brand A.
Because it's a company,
Wait, just
not some guy in his basement making batteries.
Yeah, but how do you know it's not some guy making batteries?
Because it's a company.
They would have told you
It's a
that.
company coming
It
out of
says
the basement.
brand
A.
It's like, you know.
If it were,
drugs.
if it were something like some dude in his basement, they would have said some dude in his basement.
Okay.
When they get into brands, like they're talking about real brands, they just can't name them for legal purposes. So they can't say Energizer and Duracell. Of course, I just said it on the internet, so.
Oh,
Yeah.
rip your videos.
Yeah,
You
it's
get demonetized.
That too.
I've been demonetized for about 2 years already. I don't get enough views. Thanks for that, by the way.
I watched your video last night, actually.
One video all year.
No. No, I watched all your videos before test.
Oh, okay. You telling the truth?
What?
You telling the truth?
Yeah, no, I
Okay.
he sends these pictures to the study.
All right.
Yeah. Sorry.
All right. So part F is a little bit of a weird question. It says, how would you interpret the standard deviation that you found?
You just interpret it.
Yeah. Well, it's a measure of variation. It's telling us how spread out the data are. The thing is, standard deviation is a comparative value.
Read out averages 12 hours.
Data,
Wait, is that right?
pretty close. But I'm going to change, I was going to write spread out, but I'm going to change it to dispersed. 12.133 hours on average. All right. It's a very oversimplified explanation, but that's what the Regents people are looking for. It's generally lots of oversimplification, but standard deviation is a comparative value, so we really talk about it in relation to other standard deviations. So I wouldn't even consider drawing a conclusion about this standard deviation until I found the standard deviation related to brand B, and then draw a conclusion of how spread out they are related to one another, right? So I would say, if I were drawing a meaningful conclusion to this, I would say the data are spread out, or fairly spread out. But I would hold judgment on it until I saw what the other data set gave, and then make a determination related to that. So we had the other data set popped into L2, so stat, calc 1, replace it with an L2 again. So we have the mean of 100.5, so 100.5 hours. So the average is slightly less.
What did you have for calc 1?
Stat calc 1, and then I typed in L2. Oh, did it say nearest hundredth on the last one too? Oh, jeez. Normally we go 3 significant digits unless we're told otherwise in the problem. In this case, we were told otherwise in the problem. Standard deviation for this sample, right? So again, SX, and that's your other indicator. Sometimes they just flat out tell you to find the SX. So that's the because it says so explanation, which is also a very good explanation. So how would you interpret the standard deviation that you found? Well, I would say the same thing I said here, except I would write 19.61. But I would more so rather have an overarching conclusion stating that we're looking at a data set that's more spread out on average for brand B than it is for brand A. All right, so that's what I'm gonna do here. Data for brand B.
Data.
So data for brand B are more dispersed than brand A. I mean, you could in this case write the same thing you wrote for the last question, but I don't think that's as meaningful as this statement. All right, and that goes back to the diagram on the previous page. We have the dot plots. Which one looked more spread out? Brand B. Mathematically, we just justified it. Right, standard deviation is much larger. All right, so that's your conclusion. Now, if you're looking at something that's slightly different, like the other one was 12.3-ish, and maybe this one, let's say it was 13.3. Then I would say that more analysis is required because it's not so far away from, or the values are not so far away from each other that you would be confident enough to draw a conclusion that one is better than the other. The averages are close. One is 101, the other is 100.5. So on average, they're pretty on par with one another. So this has more variation. All right, so this means that we have a lot more wiggle room in terms of battery life. Right, so if you just think of this as a plus or minus, which is not entirely what it is, but you can kind of loosely consider it that way, this is roughly 20. Take a battery at random. It's conceivable that that battery can last for 120 hours, or it might only last for 80 hours. All right, whereas in the other case, it's around 10. That battery will last for 90 to 110 hours, roughly. All right, so you're looking at less variation in the battery life. Now, depending on what you're using that battery for, that could be a big deal. All right, if I'm using it for a remote control, all right, it's a few hours here or there. If I'm using it for an AED, that's a problem. That's a defibrillator, the automated one. Like if somebody's having a heart attack, you know, like the battery in that, you want that to be predictable. All right, smoke detector, carbon monoxide detector. They tell you to change your batteries once every year. All right, why do they tell you to change it once every year?
Because they don't want you to die.
Because they don't want you to die, but batteries are not as predictable. Right, so they know that on average, yeah, batteries last for more than a year, but they're not likely to last for 2 years. All right, so change it after 1 year, even if it's still got some juice in it, because you're better off that way. You're better safe than sorry. All right, so hugely important stuff. All right, I can't emphasize it enough. You start getting into sports applications, medical applications, engineering, any aspect of science. If you plan on pursuing a career in science, you're going to be dealing with a lot of statistics. I just met with a science research student last week. She was working on migraines, a study related to migraines and long-term benefits of some treatment program. I suffer from migraines, so I was very interested in it, but she brought to me a statistical analysis that she had a hard time interpreting, and I was able to help her understand what the story was at. So, you know, like that's the application of it. I mean, just basically think of this. You're on a pathway towards calculus in senior year. The odds of you using calculus in your real life after high school, college,
0.01%.
This much, the size of Adam's head. All right, this big. All right, but the probability or the odds of you using statistics in your everyday life is the size of Adam's head. It's like this big. All right. Well, this ish, something like here.
Your head's only that big though.
Yeah, I got a small head. It's only like- So, just something to consider. All right. Not trying to talk up a course, but at least get you motivated to try to understand this material. If you never do anything with statistics again after this class, that's fine. Try to understand the concept of standard deviation. It's that beneficial.